Yep, we're still completing the square, but this time we're going to take it a step further and we're actually going to solve for x now. So here we have an equation. And obviously we know it's an equation because, well, there's an equal sign right there. And the point of an equation is to get me what x is. We want to find out what x is. Now the first thing you should see here is that x is being squared. So here you are, and here's your brain and your little thought bubble, and you should be thinking there are two answers because of the squared. And then because it's a square, you should think quadratic, parabola. How do I solve a parabola? Oh, we complete the square. So if I were to follow my steps, 1, we learned that the leading coefficient must always be a 1. Lovely, it is. Move the constant c, put it in the closet as we call it, so that the variables are isolated. It's already done for us. Somebody already moved that 12 to the other side. The original parabola must have been this. But somebody took that 12 and put it in the closet for us, and we'll take it out of the closet later when we need it. So now we can start solving. Take half of b. Hey, this is all familiar, right? X squared minus 2x equals 12. I'm going to have my thought bubble over here again. Okay, half of 2 is negative 1. Negative 1 squared is positive 1. And then I'm going to bring all that information I just thought about back into my problem. X squared minus 2x plus 1. If I add 1 to that side, I have to add 1 to this side. Now I've completed the square. I'm going to rewrite that as a binomial, and that's where this negative 1 comes in. Right? This binomial squared gets me that quadratic. So here I have x minus 1 quantity squared equals 13. Now I'm going to leave it like that because I have to solve for x. I want to actually figure out what x is. So what I'm doing now is going to get this x right here. And I guess some people told you that Mrs. Sinlensky wanted you to circle the x because that's what we're solving for. And this x is being guarded by a minus 1 and a squared. Well, the first thing I'm going to do is take the square root of both sides. That leaves me with an x minus 1 because the squared and the square root cancel each other out. But remember, we did this a little while ago. When you take the square root of something, you have the positive and the negative root of it. X is almost solved for. I'm going to take this minus 1 and move it to the other side. So we have x equals 1 plus radical 13, or 1 minus radical 13. So you're kind of looking at that going, all right, that's a nice ugly number. What does that mean? Well, we'll show you what it means. All right, so I went to my graphing calculator and I typed it in y equals. And this is the picture I got. Let me drag that picture out. Let's move this down here and let's look at this picture. Well, when we look at this picture, by now we should be very familiar with all our key points. Here's my vertex. Right here, that's my turning point. And if we took a step back before we solved for x, we would have had this. So that means my point right here is the point 1, negative 13. And it is indeed, because if I go back to my calculator and I look at my window, I can see that my y scale, see my y scale right here? My y scale is down here at negative 50, up here at 50, and a y scale of 10. So my y scale is pretty big. And the next thing I should realize is that my line of symmetry is right here at x equals 1. Is anybody seeing it now? Here is my other root. Well, guess what? This is one of my answers. See, if I take the number 1 and I add on whatever the square root of 13 is, I'll get my first root. And my other root says, if I take the number 1 and subtract the square root of 13, I'll get my other root. So this is why we complete the square. When the problem is not factorable, but the parabola still crosses the x-axis, just crosses the x-axis at really ugly points. All right, so let's try another one. Yeah, we're going to practice those factoring ones you didn't like. All right, the leading coefficient of x squared must be 1. When I look here, it's not. So I'm going to factor out a 1/2. Now my r squared has a leading coefficient of 1. This would be 12, right? Because if I distributed, I should get back my original problem. Half of negative 12 is indeed negative 6. Move the constant c so the variables are isolated. Oh, somebody already moved the constant c for me. It's on the other side. Take half the b coefficient. Okay, here's my b coefficient. Here's my little thought bubble. Half of negative 12 is negative 6. Square it, 36. Now, these pieces of information must come back into my equation. Rewrite the equation as a perfectly squared binomial. Well, I have the 1/2. I have the r. R squared minus 12r. Remember, this 36 has to get added in. Equals 2. But I'm not going to be adding on 36 to this side. Careful, careful, careful. I'm going to be adding on 18. Why? Because when I put 36 in this parentheses, that was awesome. But remember, this parentheses is being halved. Half of 36 is 18. We've got to get this step down. We've got to think, where did I put this 36? What's happening to it? All right, to continue from there, we're going to rewrite it as a binomial. So we've taken that 36 out of our thought bubble. This is where the negative 6 comes in. And that gets me 20. Now I still have to solve for x. In this case, it's an r, but we still have to solve for our variable. So the first thing I'm going to do is I'm actually going to multiply the entire equation by 2, because that gets rid of the 1/2. And again, if this step is confusing to you, it was something we should have done last year, how to solve equations. What do I have to do now? Who's guarding the r? A squared and a negative 6. Well, the next thing I'm going to do is I'm going to square root to get rid of the squared. R minus 6 is, and remember, when you take the square root, it's the plus or minus. And the last thing I'm going to do is move the 6 over. And you just found the roots of your parabola, where it crosses the x-axis, the x-intercepts. I don't care what you want to call them, but you've got to know what this number is. It's not just some big ugly math. It means something. So once again, I'm going to take out my calculator. 0.5 parentheses x squared, I don't know why I put parentheses in, minus 6x minus 2. All right, that's the equation. I'm going to graph it. Let me see what my graph looks like. Wow, it's off the screen there. So I'm going to come over here. I'm going to work with my window so you can see it a little better. So that means I have to go above 10. So let me go to, let's try 15. And my y scale doesn't have to be as big. So let's do a x minimum of, let's do a maximum of, let's say 20. And let's do my scale by 5s. So let's see what this graph looks like now. Much better. All right, so I'm going to come over here to a blank piece of paper. Going to drag this out. And we saw that our answer was 6 plus or minus the square root of 40. Right? That's what we had right there. So that means my x values, my x-intercepts, are when I take 6 and add the square root of 40 onto it. And the other one should be when I take 6 and minus the square root of 40 from it. So let's look over here. 1, 2, 3, 4, 5, 6. Is that my axis of symmetry? Yep. Now, the square root of 40 is approximately 6 point something, right? Because the square root of 36 is 6. The square root of 49 is 7. So 40 is in between 49 and 36. So it's 6 point something. So that means if I take 6 and add approximately 6 to it, I should get my next root. So here's 6. 1, 2, 3, 4, 5, 6. Got it. And the other root is when I take 6 and I subtract approximately 6 from it. 1, 2, 3, 4, 5, 6, and a little more. So that's why we find intercepts, by completing the square.